So now I've lined up. Okay. There's sun, earth, moon to scale. And obviously it's dark on this side, but what does it look like on this side? Wait a minute. I don't have an eclipse at a 2-scale model. Now maybe one thing we can do is bring the moon closer to Earth, because perhaps the Earth is too far away to create that shadow. So let's try that real quick. Let's see. Now, it would make sense that a light source that is that far away and is bright enough to reach this distance, there would be enough surrounding light, considering the size. Obviously the moon's small. that orange dot, don't get confused by that. That is not the moon. But it wouldn't be shocking to me that an object right here would not cast a shadow if this is far enough away. Because light bends around objects, remember? That's why we had like a halo. No matter what, you always have a bit of a halo until you're to like the side of the object, and then you can finally start seeing that disappear. So it actually makes sense to me why I can't, in a model that is accurate, get a shadow. But let's try to create a shadow. Let's see if the reason why is the distance, because I'm guessing that's what it is. So let's do this. And let's scale it. Let's try here. But we need to move that back over. Oh. Right there. Alright. That is still on the plane because I've lined everything up. So we've moved it closer. Okay. So it actually, I moved the moon closer at like the regular size of Earth. It didn't work. So I made the Earth bigger. Massive. Let's see, I wonder what it looks like compared to the, oh wow. I mean, at this point, Earth is bigger than the sun, right? Okay, but I succeeded in finally making the moon dark. Actually, the whole side of this Earth is dark and it's scary, right? So, I can't even find it here. It's right here somewhere. It's dark. It's gone. Bye-bye moon. No light whatsoever. So there is a limit to how far an object can actually cast a shadow. It can't cast a shadow forever.
Let's explore what happens to an object's shadow when it is moved closer to and further away from a source of light. Here we have a flashlight and a lion. When we turn the flashlight on, a shadow is produced as the lion blocks the path of light. We'll move the lion further away from the source of light. The shadow is now smaller. What do you think will happen when we move the lion closer to the source of light? Yes, the shadow gets bigger. How do you think the shadow will change if we move the source of light instead of the object? Let's have a look. If we move the source of light closer towards the lion, the shadow grows bigger. If we move the flashlight further away from the lion, the shadow grows smaller.
Alright, so let's try. Now that the Earth is bigger, let's take the moon's orbit. And let's make it come out. We gotta keep track of the moon. Okay. So that big. Can we see it yet? Nope, not at all. Alright. Moon's orbit. Scale that up even further. Let's put it way the heck out. Yeah. It's a pretty big Earth, but I think at this point, because the Earth is bigger than the light, that's why we're having a problem. I think that's probably part of it. I think that's what it is, probably. I think if the object is smaller than the light, then the light's going to bend around it quite easily. But if the object is larger than the light, then yeah, we definitely see... Oh. Nope. We finally found a point where we back up enough. Here, let's get rid of that. You can finally see. Okay? So you back up far enough, eventually that light can't cast a shadow. A shadow cannot be cast infinitely far. It eventually fades, and it's dependent on the size of the object.